Okay, let's hope the power doesn't go out yet again. So we were talking about this. We said the probability of winning is 0.005. The probability of losing is going to be 1 minus 0.005, which is equal to 0.995. I'm sorry? When we're dealing with probability, what do the sum of the probabilities have to be? 1. And since we're talking about the probability of winning, there's only one other option, right? Losing. So that's where I get my probabilities from. No, you can't. Not in this one. Not in this one. Because you're either going to win money or you're going to lose money. You don't tie. No. Now, if you win, what happens? That's right. You're going to receive $100, but we are going to subtract out the $1 that we paid, and our winnings are going to be $99, correct?
Because if you pay $1 and then they give you $100, you're still getting your $1 back. You're not getting $99 back. You're still getting $1 back. That's actually a good point.
She's right. But how much have you technically won?
$100.
No.
Yes.
You paid $1.
$1.
That means you're down $1 when you give them the $1.
Right? Like they're giving you back that $1.
Yeah, they give it back to you. You didn't win that $1.
You already had that $1.
You already, yeah. It is a good point, but unfortunately, yeah. So we're good, right? Okay. So, but it is a good point. So, you're winning, you actually get $99 back. Now, what about if you lose? Yeah, so if we lose, we're going to take the fact that we have paid in $1. Let's see, let's use this color. Nope, wrong. If we lose, we get nothing, right? There we go, nothing. But we've paid $1 to this thing. So that means that our earnings, our net earnings, is going to be a negative $1. So now let's put this all together, okay? And basically, both of these are what we call the net win. There's a difference between the gross win and the net win. Yes, the gross win would be $100, but your net win is $99 because you did have to pay $1 in order to procure the ticket to participate in this. Well, we're going to call it a net win, but it's still a negative. You've won something. It's not anything good, but, you know, we're still going to use that, okay? So what we're going to do is we're going to set up our probability distribution table, right? What are my events X? Winning or losing, right? And the number that represents winning is 99, and the number that represents losing is -1. And the probability of winning is 0.005, and the probability of losing is 0.995. And so what's my expected winnings for this game? Well, the expected winnings are simply going to be the fact that I'm going to take the $99, and I'm going to multiply that by 0.005. I'm going to add to that the -$1, multiply that by 0.995, and I'm going to calculate that, and I end up with 0.495 minus 0.995, which is going to be equal to a negative 0.5. So the net winnings, i.e. the expected value, is going to be a negative 50 cents. Okay? So, tell me how that was different from the other one. I'm sorry? I didn't need to know how many tickets were sold, though, did I? I knew what the probability was. But it was just like it, right?
Yeah. I mean, you worked.
The process is the same. Identical. Okay? Okay. In roulette, the numbers from 1 to 36 are evenly distributed between red and black. You can't read that? It is a little small, isn't it? This is 9.1. Is that better?
I don't know.
Put your glasses on. Well, in roulette, the numbers from 1 to 36 are evenly distributed between red and black. A player who bets $1 on black wins $1 and gets $1 bet back if the ball comes to rest on black. Otherwise, if the ball lands on red 0 or 0-0, the dollar bet is lost. One option in a roulette game is to bet $13 on red. If the ball lands on red, you get to keep the $13 you paid to play the game, and you are awarded $14. If the ball lands elsewhere, you are awarded nothing, and the $13 that you bet is collected. What is the expected value of the game? Yes, you can. Can I draw a picture? You mean you want a roulette wheel?
Is that the one with the red and the black and it's got like...
I don't have one in here, do I? I can get one now. Just give me a second. So, we have this roulette wheel. The croupier rolls, or he starts the wheel spinning, drops the ball in it. Now, one option in a roulette game, and this is different from the first part that was stated. A player who bets $1 on black wins $1. Basically, you're matching your bet with the winnings. It's a 1-to-1, okay? This other option is to place $13 on red. Okay, that means what you're saying is that the ball is going to land in a red slot. You're not determining which number it is. Okay? If the ball lands on red, you keep your 13, and then you get $14 from the house, which means that you now have a total of $27, right? 13 that you originally bet, plus the 14 that you get from the house. Okay? Now, if the ball lands elsewhere, you are awarded nothing, and the $13 bet is lost. Okay? What's the expected value of that particular game?
So when you actually play roulette, you don't actually call a number.
No, you can call a number.
You just have really bad chances.
Have you ever seen a roulette table? You can place your bet on any one of the numbers, or you can place a bet on the first 12 numbers, then it lands in the first 12, then it lands in the second 12, or it lands in the third 12. You can bet from 1 to 18. You can bet on an even number, red number, black number, odd number, 19 to 36. And you can bet your odds at 2 to 1 if you want.
Yeah, we bet on the red one.
So, why? No, there isn't. There's 8.
Well, it looks like
There's 38 numbers. 2 of them are green. Right here. Okay? That means there's 36 other colors, red and black. They are evenly divided, which means there are 18 red, 18 black.
Okay, watch that go red.
Okay. Then you lose. Right. So let's look at the problem. No. Okay. So let's look at the problem. Okay, we know that there are 18 red numbers. We know that there are 18 black numbers. There are 2 green numbers. $38 numbers, right? So there are 38 total possibilities. And we get that from the fact that there are 1 to 36 red and black. It doesn't say anything about the green numbers here until we get red 0 or 0, 0, so there are 2 green numbers. Yeah. Right. That's if you bet on black, yes. Now, if there are 38 possibilities, when we go to put this table together, we're looking at x and p of x, right? What are the possibilities as far as when I place my bet, I'm either going to win or lose, period, right? So, if the player wins, they receive what? In the problem itself, we're looking at betting on the red. There we go. That's what we're looking for. They receive $14 winnings in winnings. Yeah, but they already had that to begin with, right? You were not having. We didn't before, did we? No.
Hang on, we just counted this dollar up here.
No, we didn't. Where did we count that dollar, Jesse?
Because we had, okay, I'm not counting it because apparently
We're talking about net winnings and net losses. Okay? When you say, yeah, I won $27, did you really? No, you won $14 because you get back your original bet. Everybody makes that mistake unless you truly have spent time studying probability theory and gambling theory, or I should say game theory. It's a little different. Yes, everybody goes and they go to Vegas and they go, yeah, I won $1,000. Yeah, how much did you bet to get that $1,000? Well, I bet $500. So no, you didn't win $1,000, you won $500. But that's not how people portray it because that's not how Americans have looked at it. It's always been, what are my gross winnings? Because, you know, you get the weekly poker game, the guys go, they play poker, they come home and tell the wife, yeah, I won or lost so much. They don't ever tell you that, yeah, well, I ended up betting $9,000 to win $10,000, you know. So you didn't really win $10,000, you won $1,000. Okay, so we're back down here. If the player wins, they receive $14 in winnings. If the player loses, They pony up their watch. No, I'm sorry. Okay. So what are my expected, or what are my X's here? Well, if I win, I have $14. If I lose, I'm out $13. Now, what's the probability of winning? Very good, 18 out of 38. So the probability of winning is 18 out of 38. There are 38 slots. Not 18. That's 16. No, it is 18. I'm sorry. And 18 red slots. So yes, it's 18 out of 38. Now what's the probability of losing? No. 20 out of 38. Because there are 2 green ones. So what are my expected winnings? Well, it's going to be 14 times 18 out of 38 plus negative 13 times 20 out of 38. And then we go ahead and we calculate. This is equal to 126 over 19 minus 130. Actually, you know what? I'm going to do a plus negative 130 over 19. And that's going to give me negative 4 over 19, which means that my expected winnings are roughly negative 21 cents. Because you can take it, the 38 will reduce by 2, and 18 will reduce by 2, and then you multiply by 14. So negative 21 cents. So is gambling a way to make money? Good. Okay. Say what? No, that's not why they haven't legalized it.